Hey everyone, welcome to another episode of Salman's Automotive Mechanics 101. Today we'll be talking about turbocharging. In previous episodes I've talked about the internal combustion engine and how the principle and how it works and how it produces torque is at the heart of it is a piston that is forced downwards through propulsion, and the propulsion comes from an internal combustion explosion of fuel and air that's ignited, which causes the explosion, which pushes the piston down. Now, the bigger the explosion can be, the more torque is produced. The harder the piston is pushed down, the more torque is produced, and the more horsepower is produced. So to change the size of the explosion, we can change two things: the amount of fuel that goes into the explosion or the amount of air. Turbocharging is concerned with the amount of air, as the more air in the explosion, the bigger the explosion will be, as there is more oxygen. And a turbocharger works on the following parts. You have your turbines, you have your intercooler, and you have a release valve. Now, once the piston in the cylinder has finished its firing round and is pushing its power stroke, and it's pushing the exhaust gases outwards, in a normal car, those exhaust gases would just go to the atmosphere as they are. But in a turbocharged car, they will go through a pipe and into and forced to turn this turbine, just by forcing it to turn. This spinning of the spooling, it's called, of this turbine will make the turbine it's attached to spin, and this will bring in air. This will draw in air from the outside. The exhaust gases by now will be put to atmosphere, but at the intake part, at the intake turbine, which will be spinning as a result of this turbine spinning, will bring in the air, which will just come from the outside. This was passed through an intercooler. This is just to cool down the air and regulate it a bit so that it's all the same temperature. And then this will pass through to the intake manifold. Now, in the intake manifold, you have a release valve. This is just to release any air if the pressure builds up too much. So this could be, say, a little spring that compresses at certain pressure. So if the pressure in the intake manifold, because of so much air, becomes too much, then the release valve will open and some air will be able to be let out. Now, this air in the intake manifold will be then drawn into the cylinder when it does its intake stroke. This ensures that the power stroke will be a lot stronger, as there will be more air in the controlled explosion. Here are some advantages and disadvantages of turbocharging. The advantages are that you get more miles per gallon and it's more economical, as you're using the same amount of fuel, but because there's more air being put in, the explosion is bigger, so it's more efficient. That's why a lot of cars use a turbocharger, and normally aspirated cars are very rare nowadays and they hardly pass emissions tests. And another advantage, which is the main advantage for most people, is that you get more horsepower, and so this means your car is more powerful. As I've said before, with more air, the piston will be pushed down with a lot more force, and it will be a lot more efficient, so it will make your car go quicker, which is very desirable. Some disadvantages are it is quite expensive to implement all this on an engine. It'll cost a bit much to install a turbine and an intercooler and such. And the main disadvantage is turbo lag. As I explained before, the turbines have to spool up in order to draw in air, So this spooling up process does take a couple seconds. So when you put your foot on the throttle, it might not be instant to just go forward, as there'll be no air in the intake manifold yet until the turbine spool up.